Okay, so now we have to reformulate that we got in the past last part. So in the last part, what we got is maximize alpha and not alpha but gamma, maximize gamma, and that is on the basis of yi times w transpose x I plus beta should be greater than equal to gamma. So we talked about why we cannot solve this, and for that what we are going to do is we are going to reformulate our equation or our solution. Okay, so what now let's take a new kind of approach. Okay, so now what I'm going to take is I'm going to use the support vectors. Now let me explain you what those are. So let's suppose we have this class, yeah. So let's suppose we have drawn a line like this. So what I'm going to do is, okay, so what I'm going to do is I'm going to take the nearest data points from this line. So in this part the nearest data point is this. Okay, so let's make some line like here. Let's say this line is going to, yeah, and in this part let's suppose these 2 points are the closest and they are at the equal distance. So what we are going to do is we are going to make a line from them. So now these points, this point, and this are called as support vectors, and what we are going to do is we are going to make a line like them with the help of these support vectors. Now what will be the equation of these lines? So the equations of these line is going to be w transpose x plus b is going to be plus 1 for this side, and w transpose x plus b is going to be minus 1 at this side. So what we are saying here is that everything from this side is going to be plus 1, but that is just the output. But when we are talking about the line equation, so what we are saying is that we want to maximize the distance. So let me just get into it right now. This equation was w t x plus b equal to 0. Okay, now what we want is that we want that both the sides should be at the equal distance, so that we can maximize them and they will be equally separated. Okay, so what I have done here is I have taken a value like plus 1 and minus 1. Now you must be thinking that why did we took plus 1 and minus 1. Well, actually it is not necessary that plus 1 and minus 1 should be taken, but it is very good to understand the algorithm. But if you want to take something else, then you can literally take anything else. But what will happen is that when you are going to do the back propagation and you are going to find the derivative, then this number is literally not going to mean anything. But because when you are going to take the derivative, then this number is going to be just as a used as a constant, and you are going to do anything with this number. Okay, but for the sake of the argument, what we just so that we can easily calculate our formula or our algorithm, so what we are going to do is we are going to take plus 1 and minus 1, and yeah, so we are going to take plus 1 and minus 1, and what we are going to do is we are what we will try to do is we will try to maximize this distance. Okay, and you must be thinking that how these points are going to be lie on this part. So for that we can normalize our data, and there are so many techniques, but now let's just move on with our part. So now this is the new technique that we are going to use. And now what I'm going to do is I'm going to find the distance for this part, and I'm going to find the distance for this part. Okay, Now let me just find that distance first. Okay, so the first distance is t, and it is going to be what we can say is w transpose x plus p and divide by norm of L2 norm of w. Okay, so this is going to be the d1, and d2 is going to be similar. So this is going to be, you can say, w transpose x plus p divided by L2 norm of w2, and in this part this x will belong to positive class and this x will belong to negative class, because we are only considering these parts in this case and these parts in this case. Okay, so that's what we are doing here. Now this distance is this, so what you can say is that, as we said earlier, like we are because we are finding the distance, so we are gonna take the mode of them. Okay, now we have considered that, okay, this line is going to be 1 and this line is going to be -1. So what we can do is, to find the total distance, we can use d1 plus d2. So that is going to be 1 plus 1, 1 plus 1, no, yeah, just let me write this. So this is going to be the output, and this is a positive one, not a negative one, because we are using the mode, and this is going to be 2 divided by w. Yeah, so this is the distance that we have to maximize now. Okay, and this is the output that we have to maximize now, and let me just rub this again. So the distance that we have to maximize is 2 divided by. So there are two ways to maximize this. Either we can just maximize this like this, and because we are using it like a loss, that okay, we want to reduce the number, we want to reduce the loss kind of. So instead of writing it in this form, what we can say is that we want, instead of maximizing this part, what we want to do is we want to minimize this part, divide by. And I hope that you are getting why these things are equal. Either you can maximize this or you can minimize this, it is going to be the same. Okay, so it is going to be the same if you maximize this and minimize this. So let's suppose, if you want to maximize this, what you can do is you can minimize this value. Okay, and if you do this here, then it is going to work as well. So this is how you are going to basically, this is what you have to minimize right this time. So you have to minimize this part, and here also we have a constraint. So what constraint do we have? We have yi multiplied by w dx plus b should be greater than equal to 1. And why we have this constraint? What we are saying is that, okay, so let me again write this. Let's suppose we have this, we have this line, we have this line, we have some point here, we have some point here. So what is this? This is 1, this is 0, this is -1. Let's see. So what we are saying is that, okay, if this number is positive, then this class is also going to be positive, and that should be greater than 1, because each and every other point should lie beyond this part. So if it is greater than 1, so it is okay with us. Okay, and if we talk about this side, so what we are saying, okay, if the number, if this is negative, so this is also going to be negative, then we are going to multiply them, then that is going to be positive, and that should be greater than 1. So if it should be greater than 1, it means that every point should lie beyond this line, and in this side every point should lie beyond this side. Okay, so that's why we are doing this. But right now, the problem that we had earlier, the problem was that we had to maximize the gamma, and that gamma was being used in this part, in this constraint. But in this part we have to minimize this, and this is not being used anywhere here. Okay, so you can do whatever you want with this, it is not going to affect here. Okay, so now one more thing is that if you want to see like what we are doing here, why is this like this. So as I said you as I told you earlier, that we are finding the distance here. So how you are going to find the distance from this point to this point is by doing the L2 norm. Okay, and what is the distance from as we found out earlier, the distance is 1 divided by W2 norm. Okay, L2 divided by W2 norm. So we can cancel them out, and this is just being considered as normal math. I hope that it is clear why we cut them out.